Um, yeah. So anyone, like, feel free to like interrupt and ask any doubt, or maybe even now, like, let's. So just to uh, start with, does everyone understand like the one-on-one mapping between consumer and partition? Why we do it? Like, let's say if I just have to ask this question, why we do the one-on-one mapping? Like, does anyone want to answer this?
Which thing? A one-on-one mapping?
So, like why we do the one-on-one mapping between partition, each partition, like why each partition is mapped to just one consumer and not many consumers?
Um, one message can be consumed by just one, right? One partition. Oh, okay, like it is like said that, but why is it like that? Okay.
Sorry, I didn't get you, Asim. Can
No, I was trying to understand the question.
Okay, I meant to say,
I tried to answer it, but I reiterated the question. So, uh,
yeah, anyone else? So Asim, like, just to clarify, like, we have a group of consumers, right? And yeah, in Alexu we were looking at like whether multiple consumers can consume from same partition, or whether just one consumer can consume from one partition.
right,
So we have a one-on-one mapping, right?
that's right.
Yeah. So
In a consumer group, one consumer would consume that partition.
correct, correct. So I'm just trying to ask, why do we need that thing? Like, why is the requirement that only one consumer should consume from one partition?
Or for the race condition.
Sorry.
Race condition, like
Yeah. Yeah, correct.
and
So let's say,
resource locking.
correct. So there could be read and write request. Correct, right? So read will be reading a message, and write is nothing but writing the offset commit. So if two of them consume, then we can have a race condition. So what does race condition mean here is, like, one consumer consumes and it is trying to commit the offset, another is trying to read the message. So if that's the case, then we will never be able to know whether a current message is getting consumed or not. Because if the read goes first before the offset commit, right? So let's say there are two consumers trying to consume a message. The first one reads it, processes it, and it wants to commit back the offset. So if first one has consumed the message, we don't want the another to consume it. Otherwise, there will be a duplicate processing. Consider a billing scenario like a trip completion event here. If a trip is getting processed by one billing service, then the payment will be charged by that billing service, and then it will commit the offset for that. But let's say if there is another consumer trying to consume the same event, then we will have a duplicate payment charges, right? So in order to avoid the duplicate payment charges, only one consumer should be able to consume. So how can that be prevented? It's like basically what's the race condition here is, let's say first consumer is faster, it will read earlier, and it will process it, and it will, by the time it tries to come back to commit the offset, let's say second consumer just reads the message before the first one commits the offset. Then second consumer will see that this message is not, it doesn't have a committed offset, so it will try to consume that message. But now we are consuming it second time, and then once the second consumer has read the message, then let's say first consumer commits the offset. So there will, this is basically the race condition. The answer is not idempotent. It basically depends on whether the read wins or whether the write wins. If the write was successful, then we won't have a duplicate processing. If the write isn't successful, if the write doesn't go through before the read, then we will have a data duplication. So basically there is some inconsistency there. So this is the issue we were trying to prevent, the like a message duplication. Or also, if the order is required, then definitely this is not a correct way. Let's say we want to consume the messages with their sequence number itself, then this won't work out well. So that's about it. So my next follow up is like, would the consumer proxy, which is trying to consume a message in a batch and trying to distribute it to multiple messages, like the sort of parallelization we were talking about yesterday, do you guys think that would avoid the duplication or not? Like, any thoughts about duplication in this scenario of consumer proxy?
Um,
Is the
Rajat, can you please just
Say the question again.
reiterate in fast? I just joined. Sorry, I
Yeah,
thought it.
so I was just plain asking a base, like the question or the, I was just trying to ask why we have one consumer tied up with one partition. So basically, in a consumer group, why only one consumer should consume from a partition and not multiple consumer trying to consume from a partition? So I was just trying to ask a question, like.
Yeah, so basically in consumer group, one consumer group, we have multiple consumers, and one consumer is getting some data, the other consumer is getting some data. But if the two consumers of the same consumer group will get the same data on the both of the threads, they will have the same messages.
Correct.
So yeah.
Yeah, so now how would that be prevented using this consumer proxy? Like, does like I was just trying to ask, like, would using the consumer proxy change that or nothing? Like, or will it remain same? Or will there be a duplicate consumption of messages, or there won't be duplicate consumption? Like, using the consumer proxy would make any difference here or not?
Yeah, it will. First of all, it removes the bottleneck, since we have like one consumer will read from one partition at any given time. Only one consumer can read from a partition, so there is a bottleneck if there are multiple consumers waiting to read from that partition. So consumer proxy resolves that issue and allows the multiple processing, message processing. Secondly, since consumer proxy have is grouped uh, to, or is maybe it is scheduled, configured to read from one particular partition. It is pulling all the messages from that partition and kind of acting as a load balancer, wherein finding the consumers and or allocating it to the different consumers. So that job is done by the consumer proxy now. So it will definitely avoid that race condition or any duplication of the reading or writing back to, or committing the offset. Yeah, that's my
Sorry,
answer.
sorry. I didn't quite get it. Can you come again?
So I said consumer proxy. First of all, one consumer will read from partition at any given time. So while one is reading, other consumers cannot read from that partition, right? So this is the condition. To resolve this condition, we got consumer proxy. So now,
Yeah.
whatever the messages are there in partition one, those are configured to be received by a one particular consumer proxy. Now, once in a batch, consumer proxy gets all these messages. consumer proxy acts as a kind of load balancer, um, uh, dividing the messages load among different consumers. So it will so it will the way it is configured, it will avoid the race condition, and it will avoid duplication of reading the messages.
Yeah. So yeah, that's correct. Except one minor like nitpick there. Here we still have just one consumer proxy consuming from one partition, right? So there won't be any rest condition here. Like if there is just one node consuming from one partition, then there won't be any rest condition. Everything else was like correct, like to the point.
Okay. But
Yeah.
still, proxy is like one proxy is catering to multiple consumers, right? Then how it is? I mean, I know that there is no race condition, but there are still chances that so consumer proxy is allocating the messages to the consumer instances rather than instance reaching out to the consumer proxy, right?
Correct.
Okay. Okay,
So
got it.
if the proxy, basically, since the proxy is fetching the messages from the partition, is the responsibility of the proxy to to distribute one message to one consumer only, right? So if one message is getting distributed to one consumer, and if it doesn't work, then it can retry, but it has to keep track of that, basically, that the message didn't succeed, or any kind of avoid deduplication should happen while it distributes the message. But as long as it distributes to just one consumer and it returns back success or fail response, then we are good. The only condition we need to take care of here is timeouts. So there has to be a sufficiently higher timeout limit here, so that there shouldn't be a scenario where the consumer proxy node thinks that the message wasn't processed successfully, but actually the consumer service did process it, except it didn't reply back with a success response. So so let's say if the timeout happens before it replies back with success response, then the consumer proxy node will assume that the message failed. So in that case, it might go for a retry. So there should be a sufficient high threshold for timeout here, and that could prevent the like duplication. Sorry, the duplicate message consumption. Does it make sense? This is a active like this is like, consider this as a typical interview scenario, and these are the kind of questions that they could be asking you, like how to prevent duplication and stuff. We just need to set a higher timeout, and then that would take care of it.
Where you are putting the timeout?
Timeout for the response from instance, uh, consumer service instance to the proxy node.
Mm-hmm.
So let's say a proxy node consumes message from partition 0, 100 and 100 to 106. All seven messages are
Mm-hmm.
consumed. It tries to distribute the message number 100 to instance 1, right?
Mm-hmm.
So let's say if that's a visa message for visa processing, it
Mm-hmm.
takes longer. So if it is known to take longer,
Mm-hmm.
then we should have a sufficiently high timeout. Otherwise, let's say if the request, let's say if it gives the message to instance 1, and it expects the response, either success or failure, right, from it. So if we try to basically expect a response, let's say within 1 minute, and let's say
Okay,
if
you mean like retry If we know that it is going to take longer time, we should put a high timeout so that it should not retry again and again.
See, if the message got processed, but the timeout, let's say the message got processed at 1 minute 10 second,
Mm.
but we had a timeout of 1 minute. What
Mhm.
will happen in this scenario?
Then it will retry again.
Correct, but it will go for a retry, but the message did get processed at 1 minute 10 second, right? And then
Yes.
if it retries, then there will be a duplicate message consumption, because the proxy thinks that the message didn't get processed correctly,
Mm-hmm. Mm-hmm.
but actually the instance did process the message, except it didn't process it within 1 minute, it processed it at 1 minute 10 second.
Okay, so what is the solution?
So we should set a threshold of timeout sufficiently higher. So let's say if we expect a response of 1 minute, that then the threshold should be, let's say, 2 minutes or 1.5 minute, like
Got
something
it.
like that. So that will ensure that there are no borderline cases like this.
Mm.
So I'm just basically trying to break the system just to ensure our understanding whether we will be able to handle this scenario in interview or not. So that's all the thing that I was trying to, like, just to
Mm-hmm.
internalize the current scenario.
Got it.
Okay, yeah, sounds good. We can go forward, maybe. Yeah. So, do you guys think we should discuss this this in question and answer format so that we can brainstorm better? Like,
Yeah, yeah.
so actually, I did posted. We did basically we discussed yesterday as well, right? If we can actually discuss about actual interview questions or not. So I posted this, couple of question bank that I found out. These are pretty good questions. Like,
Yes, Sagar,
yeah.
I do have a couple of questions. So regarding that, the consumer proxy. So one is that what are the trade-offs we have here with the consumer proxy?
Uh-huh.
How do we actually manage the ordering, the semantic what partition provide that the order of the message processing? So
Okay.
I believe that with consumer proxy, do we still support that, or if yes, then how it actually does? I believe that it should not.
So by semantic, do you mean to say, let's say, at least once, or
No,
uh,
no. So the uh, order of these messages in a partition.
yeah, so the consumption order or order of commit, I think it's clear that we won't be able to support a orderly commit. So there has to be out of order commits allowed for such scenarios, right? Because what we are trying to do itself is prevent the head of line issues, right? Like, or the reason we had the bottleneck is because we were consuming serially and committing the offset serially, and let's say a poison pill scenario occurs, then the consumption is blocked at that particular message, whereas subsequent message could get consumed faster, right? So essentially we want basically artificially to go away from the out of like the orderly commit scenario in order to consume faster.
Okay, so I got it. Yeah, so the consumer proxy, the trade-offs are to improve the throughput.
Improve the, yeah, the only goal here is to improve the throughput. the
Okay.
latency the latency won't be affected by consumer proxy in itself, just
Latency will
improve.
not be, but the trade-offs are here that we are okay with the out of order, but
Yeah,
we want to improve that. Okay, got it.
yeah. So actually, in this article they typically consider the trip completion scenario. So trip completion scenario is not basically like it is not sensitive to the orderly commits, right? As long as we have at least one semantics worked out successfully,
Got it.
it
Okay.
shouldn't matter, the order shouldn't matter. What was your second question?
Second, I mean, I was thinking that, I mean, uh, how they actually take care that as one is that the order, but they are pulling the message in the batch. So I believe that the proxy will take care and and sorry, sorry guys, I'm driving. So this, so as we are okay with the out of order, so in that case, if some of the message either failed or getting delayed, so somehow the proxy will take care that and for the complete batch. And once the batch complete, then it will write the whole batch as a offset and pull the next batch.
Correct, correct. So, like, just maybe just a spoiler alert or a spoiler. Like going forward, we will be discussing about dead letter queues. So the failure scenarios you are talking about, right? Like some sort of retry mechanism or ensuring that the message definitely gets processed successfully. There are dead letter queue implementation in the subsequent reading that we will see. So that takes care of any failed messages, even on the consumer instance or consumer service side part.
So this consumer proxy, so let's say a standard component or this the document what you guys are reading that over, they actually trying to show that how they actually solve their throughput problem.
I think it's just Uber specific thing, but the
Okay.
reason we are learning it is because it's a very logical step to or logical thing to bring in. But to answer your question, it's Uber specific thing. It's not any standard or like any generic component.
Okay.
But I think it's not a bad design if we can introduce this to avoid any bottleneck or wherever we need a high throughput requirement, including the fault tolerance scenario. This is a good thing to discuss about or bring in. Basically, we are just adding a gateway component or a load balancing component with fault tolerance or retriable stuff. Something which we have in exponential backoffs, right?
Yeah, makes sense. Thanks.
Any other doubt, anyone? Like it's a good discussion, like feel free to ask any doubt, even though like we should discuss about, we should think about trying to break this system, or trying to break our assumptions just to learn it better, or like think about like what could be the limitation. So far we are not able to come up with any limitations whatsoever with this system, like, so that actually worries me or like concerns me, because like there must be some limitations that this system should still have, uh, which should come to us, like we should come to our mind. So on a latency side it's giving good improvement. It's on a consistency side it is giving good improvement, at least. So yeah, that's why actually I was thinking about like what could be the limitation. Okay, let's go forward, let's read.
Anyone else is interested in reading?
Yeah, let's try to like rotate, whoever hasn't read maybe.
Where are we starting from? Where did we leave?
I think we covered
Out of order commit, we completed first paragraph.
Okay, I'll take it.
yeah. Can you scroll up a bit? Like I just wanted to add a link to from yesterday's one. So we were actually discussing about how the parallel processing takes place. and that's basically the load balancing scenario, and how that could basically prevent the poison pill just by mere parallelization. And since we are consuming the messages in a batch, even the slowest or even the slowest message processing message getting processed won't affect the subsequent messages being consumed, and our latency will be driven by the slowest message because we will be committing the offset in batches too. So that's just a point to be noted here, like from yesterday's discussion. Like the offset commit is still happening in the batches, so the slowest message will dictate how soon we can commit back the offset and how soon we can start consuming the subsequent batches. Yeah, so let's move forward.
To address this problem, we introduced out of order commit from consumer service to consumer proxy. In other words, consumer services can commit to a single message to consumer proxy. Unlike Kafka, where a commit indicates that all the messages with lower offsets are also committed, a consumer proxy commits only marks that single message as committed. In order to clearly distinguish these concepts, we call consumer proxy single message commit as acknowledge and Kafka commit as commit. Consumer proxy tracks which offsets have been acknowledged and only commits to Kafka when all previous messages have been acknowledged but not yet committed.
Can we read this again? This actually is the gist, I
Yeah,
think.
to address this problem, we introduced out of order commit. Actually, let me start from the beginning, the first paragraph as well. The naive implementation of parallel processing a batch of message addresses the partition scalability problem, but it does not address the non-uniform processing latency problem. If the first message in a batch has not been committed to Kafka, consumer proxy cannot fetch the next batch, which blocks the consumer from making progress. To address this problem, we introduced out of order commit from consumer service to consumer proxy. In other words, consumer service can commit a single message to consumer proxy. Unlike Kafka, where commit indicates that all the messages with lower offsets are also committed, a consumer proxy commit only marks that single message as committed. In order to clearly distinguish these concepts, we call consumer proxy single message commit as acknowledge and Kafka commit as commit. Consumer proxy tracks which offset have been acknowledged and only commits to Kafka when all previous messages have been acknowledged but not yet committed. So
Is any doubts anyone here?
Yeah, I did not understand this line. Unlike Kafka, where commit indicates that all messages with lower offsets are also committed, a consumer proxy commit only marks that single message as committed. So my understanding of this line is, say if there are 100 to 106 messages in partition 1, when there is no consumer proxy in the picture and messages are being read one by one by consumer, unless and until 100 message number 100 is committed, 101 cannot be committed. Is my understanding correct?
Yes. That's a
Okay.
conventional way, right?
Yeah, conventional way. But in consumer proxy, uh, since it has a pool of messages, consumer proxy has a pool of messages. uh, the commit consumer to consumer proxy commit, which is called as acknowledge, happens in any order. Like if 100 has finished first, it will be acknowledged. If 105 is finished second, it will be acknowledged. So on and so forth. So it's a out of order commit, and consumer proxy keeps the track of which all messages are acknowledged by the consumers, and only when the entire batch is complete, uh, it will commit those messages to the partition, Kafka partition.
Yeah, that itself, I think, what you just said, that itself explains the two statuses that they are talking about, right? So look at it this way.
Actually,
Look at it.
three statuses. Again, I have one more doubt, but once you clarify this, I'll ask.
Okay, okay. So look at it this way, as they have shown in this proxy node one diagram. So what we have is 100, like 100 to 106 messages. 100 and 101 are marked in green. 102 is marked as gray. 103 is marked as yellow. Okay. So these three are three separate statuses. So let's say all 7 messages are distributed among these 5 instances. We get a response back from instance one as a success message. So we have it for the first message, which is 100. We can go and commit it. Then we get a response back for 101. And before 101, all the lower offset, which is 100, is committed to. So we can commit 101 as well. Now we don't get acknowledgement, we don't get any response for 102, but we did get a response for 103. So since we got the response for 103, we won't be able to mark it as committed, because because 102 is still missing. So any of the lower message response is missing, then we can't commit any message. But we did get a successful response back. So instead of committing it, we just mark it as acknowledge that we did get a successful response.
So,
Okay. Now what will happen is it will go about looking for 104. We don't get any response for 104. Then it will get a response for 105. It will again mark it as acknowledged, because 104 and 102 are not complete. So 105 is marked in yellow, which is acknowledged, and 106 is also marked as acknowledged. So what will happen is, after some time, at least with some retries or whatsoever, some way we did receive the acknowledgement for 102, or let's say the response for 102. So now since 102 has all the lower offset available, like 101 is committed, 100 is committed, we don't need to mark 102 as acknowledged. We can very well mark it as committed. The moment we mark 102 as committed, we can also mark 103 as committed, because that whole sequential lower offset has a committed status. Then we can wait for 104. Once we get 104, we can mark all of them as committed.
okay. So my understanding here is, for those all 7 messages, out of order commit is applicable as long as it is with consumer proxy. But as soon as we are committing, the consumer proxy is committing it to the Kafka cluster, it has to still follow that old pattern of all lower offset has to be committed. Means, if I have 102, 103, and 104, for which I have received the acknowledgement, but if my 100 and 101 have not yet received the response for, then I cannot commit 102, 3, and 4. I have to wait for 100 and 101 to complete. Then only it can be committed to Kafka. So Kafka still expect that the lower offsets are committed first, right?
Correct. Correct.
Okay.
Does anyone has any better explanation than mine, or has any better or any other logic than mine? Just trying to validate. Uh,
Sorry, I was distracted. But what I understood from here, that this consumer proxy node it's still committing the lower offset only, but here we are just getting acknowledgement that yes, this message has been processed and it will not retry again. So for that purpose only this is getting helpful. Otherwise, in Kafka cluster, we are committing based on the lower offset, like sequential offset only.
Correct. Yeah. So to the Kafka partition, it's a sequential commit only. But since we are just changing the status to acknowledge instead of commit, it looks like an out of order commit.
It's not a commit, like I think the wording is little misleading. It's
Yeah.
not commit, but yes, to not the Kafka commit, but it's like acknowledged and it will not retry.
Yeah. Yeah.
Kind of that. Yeah.
So, Sagar, here my confusion was, it is clear now, but I just want to state because it came to my mind. When we say that consumer proxy does a batch commit, uh, I was of the opinion that all 100 to 106 together it commits. But no, as long as it finds the in whole heap of messages or in entire list of messages, it finds lower messages which are acknowledged by consumer. As long as it finds the segment or one or more messages, it just goes and commits it to the Kafka, and that commit is called as batch commit, right?
No, I think batch commit or individual, this what we are talking it now. This is a configuration. Based on the configuration, you can design like 100 to 106, and unless it doesn't come, do not commit to anybody. Do not commit to the partition 0. Or otherwise, if
Okay, got
yeah,
it.
yeah, I think so. I mean, I have not worked, but it can't be like that.
Or yeah, Sagar can explain.
Yeah.
Sorry, even I missed your point, Bahana. Like, what did you mean to say? Like, when you say, uh,
Configuration, like it would be configurable, like in the batch only you need to commit, or individual message from the lower offset you can commit, like sequential commits you can do, or in a one every message everything is committed, like acknowledged and everything has come from the consumer service, the response, then it is going to commit in the batch.
can you scroll up a bit? Slightly, yeah. So here, Bhavana, in the second line, if second paragraph, second line, consumer service can commit a single message to consumer proxy. That is slightly confusing me with what you mentioned. um,
Uh,
like,
Sagar, I'll explain what she's trying to. So I have a doubt. When you say batch, what do you mean by batch? My confusion was, a batch is like in this diagram. If you see, there is consumer proxy node one and node two. So for proxy node one, the batch consists of 100 to 106 messages. So one batch is consisting of 7 messages. But when I read through this article, I came to know that out of 7 messages, first 2 messages it already committed, while it is still waiting for rest of the messages. So, to answer my doubt, what Bhavna is saying, that batch is something not one or two messages, but some configuration which is set as some number, say 100 messages. Consumer proxy will commit only when it is 100 messages ready to be committed, it will go and commit. So
okay, so you
this,
mean to say, like,
uh,
okay, I think I understood. So basically, from consumer service instance to consumer proxy, there will be this acknowledged status. But whenever the proxy is committing back to the partition, it will always be in a
partition
batch.
batch, yeah. So in my
Makes sense.
opinion, the batch was this 7 messages. For in this context, it is 7 messages. But what Bhavna is saying, it it may be or may not be, because it is a config, it might be a configurable item
Understood.
wherein a batch is defined by the at the consumer proxy level. When it receives say 50 messages, don't, then only it will commit. Yeah.
Understood. Yeah, I think that explains the dead letter queue logic as well here, because like the dead letter queue is nothing but for the failed messages like 102 and 104. We will be retrying, so we will put 102 and 104 into a separate queue, which can then retry again. So like I think that is perfectly fitting here.
Okay.
So between consumer service instance to consumer proxy, we have acknowledge versus um, so all the responses would either be acknowledged or commit. But in from proxy to partition, it will always be commit.
Yeah.
Well,
Who
Is
was
it
it?
clear, Asim, so far? Like,
yeah,
okay, perfect.
I'll continue. Uh, with out of order commit, consumer proxy fetches several batches of messages, inserts them into the out of order commit tracker, and sends them parallelly to consumer services. Starting from the last committed message, once a contiguous range of messages are acknowledged, consumer proxy commits them to Kafka and fetches another batch of messages. Therefore, consumer proxy makes progress even when previously fetched messages are not being fully committed to Kafka. This solution mitigates the transient head of the line blocking issue, however, it still has some limitations. There,
Asim, can you read first paragraph again?
with out of order commit, consumer proxy fetches several batches of messages, inserts them into the out of order commit tracker, and sends them parallelly to consumer services. Starting from the last committed message, once a contiguous range of messages are acknowledged, consumer proxy commits them to Kafka and fetches another batch of messages. Therefore, consumer proxy makes progress even when previously fetched messages have not been fully committed to Kafka.
Does it make sense? So basically, what they're trying to say is they can keep moving the needle, they can keep moving the pointer of the batch, like whatever messages we are consuming, as long as we have committed all the previous messages. So that actually
Not as long
Not
as,
Uh,
not it does not say that as long as previously consumed message is committed. It is
yeah,
saying
I mean,
even,
acknowledged from the consumer proxy.
I think acknowledgement is sufficient to
oh my
move the
bad,
needle.
yeah, my
Yeah,
bad, yeah, yeah. No, but the continuous range of messages acknowledge is nothing but we can, those are nothing but that means basically they are convertible to commit, right? Like
yeah.
Correct.
So
only
if
if it's non-contiguous range, we will have acknowledge versus failed message status, right? As long as it is contiguous, we can very well mark them from commit, from acknowledge to commit, right?
Yeah, yeah.
That
So the point here is, say if the batch is configured as 10, so it will pull first 10 messages out of, and it will send it to consumer. Out of that first 3 messages, it got the acknowledgement, but rest of the 7 messages it did not yet get the acknowledgement. First 3 messages it will commit, 7 will remain acknowledged and uncommitted, then it will pull the next batch.
right.
Correct, correct, correct.
And
Okay.
those seven, they won't be acknowledged. They will be in the out of order commit tracker.
Yeah, yeah. So yeah, correct, sorry, my bad.
I'll continue. This solution mitigates the transient head of line blocking issue. However, it still has some limitations. There may be message duplication on Kafka consumer group rebalance when consumer proxy needs to fetch acknowledged but not committed messages again. Second, poison pill messages can never be acknowledged out of order commit tracker, which leads to the result that messages fetched after them can never be committed to Kafka. When a message commit is blocked, consumer proxy will not be able to fetch and dispatch more messages. This did not make sense. Um,
First of all, what is transient head of line blocking issue?
I think basically it means that like it'll keep on continuing the instead of blocking and waiting for all the acknowledgements and commit, it'll keep on like going forward with the batch processing.
Yeah, head of line blocking issue was the first we wanted to solve it. Like the first Visa and then MasterCard. That is called head of line blocking issue.
Okay.
For that, we introduced dead letter queue.
Okay.
Yeah, it's just a terminology, nothing.
Okay. Asin, can you read first point again?
There may
Sorry, guys, I was talking about talking on mute. So the transient one is nothing but like it will be inconsistent, right? It could be any random way of blocking it. Like we don't have a specific sequence of how many will be Visa and how many will be Mastercard, right? So that's just a transient nature. Like there is no consistency there. So that's why the head they are calling it as a transient head of line.
Transient is intermittent, right?
Yeah, intermittent blocking. So
Intermittent head of line means the person who is standing in front, unless that person's is processed, work is processed, it will not allow anybody else to work, go
correct,
ahead and work.
correct,
So okay, so if visa is in queue, first in queue, it will not allow the next message to process unless it is committed. It is read, written, and committed. Okay.
correct.
Uh, s- so this solution mitigates the transient head of line blocking issue. However, it still has some limitation. Yeah, Asim, can you read the first point?
There may be message duplication on Kafka consumer group rebalance when consumer proxy needs to fetch acknowledged but not committed messages again. Any comments on this?
I think the solution
I
mitigated Canada, but however, it still has some limitation. There may be message duplication on consumer group rebalance when
This is
consumer.
what you explained earlier, that um, timeout issue that you explained, right? I
Okay.
think it is talking about that.
Okay, okay. Let's say basically if one of the instance consumes them, one of the instance start processing the message and just dies. So those messages needs to be redistributed. Is that the one? But I think there is no
No, no,
rebalance
no,
there, right?
no, no. So this one, what it is saying, there may be message duplication on Kafka consumer group rebalance when consumer proxy needs to fetch acknowledged but not committed message again. So what it is saying is, say one consumer, there is one consumer group, and a proxy doesn't receive the response, or the it received the response but it is not yet committed. So
Oh, okay,
that,
okay.
huh,
Let's say if we are directly acknowledging it back to the partition, um,
no,
uh,
no, no. It is not talking about partition. I think in Kafka consumer group itself, there is rebalance happening. So in Kafka consumer group, if there is more than one consumers, type of consumers, and the message is read by one. but other consumer has not read the message. So that when that rebalancing is happening, this consumer proxy needs to fetch the acknowledged but not committed message again.
If the rebalancing is happening among the consumer group itself internally, then it should be consumed only once, right? By only one consumer, right? There is no point of fetching again if the message is already processed.
Probably what I understood out of this, my I might be thinking hypothetically, but in a consumer group, a consumer group is a group where one message is consumed by multiple consumers. They are grouped together. Okay, so one message when say consumed by consumer one in a group, but after consuming and acknowledging it, for some reason it goes down. Consumer 2 and 3 in the group, they have not yet read the message, or they have not yet consumed the message. So by the time that uh, by the time that the other two consumers are consuming that message, there it can be a duplication.
Okay,
Is that
okay, I
what it
know
is
that.
saying?
Yeah, in case whenever the restart happens or whenever the
Yeah.
instance crashes, then the rebalance will take place, and in the rebalance case, it would try to basically reconsume the non-committed messages, just to ensure that uh, the non-committed messages do get consumed with at least one semantic, right? Like we need at least one success, but
But in this, what I have not understood, when consumer proxy needs to fetch acknowledged but not committed message again.
yeah, maybe let's take it like we can think about it on the other side, like and then come back to the discussion tomorrow on this point, or let's proceed at this moment.
Okay. Yeah, see, you can read next one.
Poison pill messages can never be acknowledged to out of order commit tracker, which leads to the result that messages fetched after them can never be committed to Kafka. When a message commit is blocked, consumer proxy will not be able to fetch and dispatch more messages. In practice, message duplication is not a problem at Uber since consumer service usually have built-in deduplication mechanisms regardless of whether Kafka messages are duplicated or not. Um, I
Can
wasn't.
you?
So, yeah, sorry, go ahead.
Oh, I was saying I did not. Can you, Sagar? Can you explain poison pill message once again?
Yeah, it's the is the retry one that I was talking about, like the timeout one, let's say. The poison pill message is the one which takes forever. There is no response back, either failed or success. So it keeps waiting up, or it keeps retrying it, and with a higher timeout wait, just to at least get one successful processing response from the service instance.
Okay. Okay, got it.
That's the poison pill message. Like with one message taking exceptionally longer.
And because of that, rest of the messages in the queue, which are queued subsequently, cannot be committed to the Kafka.
Correct.
Okay. When the message commit is blocked, consumer proxy will not be able to fetch and dispatch more messages. Okay, got it. Yeah. So are we continuing or stopping here?
Um, how about you guys? Like, let's just read next two paragraph, like the letter Q first two paragraph, and then we'll come back to discussion again. Like, let's discuss it tomorrow, but read it today.
Okay.
Dead letter queue. In many cases, consumer services don't want to be blocked by poison pill messages. Instead, they want to mark these messages for special handling, save them, and come back to revisit them later. Straightforward. Okay. We added dead letter queue DLQ topic that stores poison pill messages. Consumer services can explicitly instruct consumer proxy to persist messages to DLQ topic by sending back a gRPC error code. After a poison pill message is persisted to the DLQ Kafka topic, it will be marked as negative acknowledged. In the out of order commit tracker with DLQ consumer proxy tracks which offset have been acknowledged or negative acknowledged, and only commits to Kafka when all previous messages have been acknowledged or negative acknowledged but not yet committed. So
Yeah,
basically,
that's pretty much straightforward, right? Like,
right. It's just saying that whatever poison pill messages there, we just put them in a DLQ topic, and then those DL like it revisits them, also gives them a negative acknowledgement, and then it sorts according to the acknowledgement, which is like positive or negative acknowledgement, and commit only the acknowledged messages and leave the negative acknowledged messages.
What is this negative acknowledgement? Acknowledgement is always.
Some kind of, I think, flagging, I believe, just a term for a flag or something.
Mhm. Mhm.
it's just another, yeah, flag. Yeah, that's a bit perfect word. Yeah.
But that one is also in Kafka cluster, the topic. Did you see, notice that?
Yeah, dead letter queue is part of Kafka cluster generally. The whichever message we want to go for retry, we put it into that dead letter queue topic.
Mm.
Okay, let's stop here.
All right.
Thank you everyone. We
Thank
we
you.
can stop the recording at this moment.
Yeah.